So today we're going to be looking at line integrals of scalar functions by reference to this question here. A vertical fence constructed whose base is along this quarter circle here in the first quadrant and whose height above each point on the curve is defined by that. Find the area of the fence. Okay, so let's have a look what we're looking at here, courtesy of desmos.com. Thank you very much. Let's just change the pen colour. That's probably a good idea. Right, so basically if we look here, that is the curve x squared add y squared equals 4 in the first quadrant. There's the x-axis and there's the y-axis. And this thing here is the function x add y squared above it. And what we are looking at is, imagine that a fence was built along this curve here up to that surface like that, and they build a fence like that. What is the area of that fence? And I've got Desmos to do it much better than I have. So here's the x, here's the y. Again, this is x squared add y squared equals 4. There is our function x add y squared, and here the red bit is the area of the vertical fence that we have to calculate. Okay, so how do we do that? Let's go back into black pen. How do we do that? Well, it's a line integral. So basically, let's get a little bit of space here. So the line integral is sorry, my apologies, is basically equal to the integral of f ds along the curve C, where ds is a tiny little increment along the curve, and there's dx and dy. So dx here is in the x direction, dy is in the y direction, and then by Pythagoras we have that delta s equals the square root of delta x squared add delta y squared, which also gives us that ds dt equals the square root of dx dt squared add dy dt squared, which we're going to use in a minute. So basically we're going to use parametric equations, and basically this here becomes, using parametric equations, the integral from t equals a to b of f of x of t y of t times by ds, which is the same thing as the integral from t equals a to b of f x of t y of t ds dt, which is where this comes in, times dt. Okay, and basically what we have to do is we need to evaluate that. So what we're going to do is we're going to parameterize the curve x squared add y squared equals 4. So x squared add y squared equals 4, which is the curve that the fence is going to be built along. So what we're going to do is we are going to let x equal 2 cos theta and y equal 2 sine theta, and that is going to go from 0 less than or equal to theta less than or equal to pi by 2. That will take us along the entire first quadrant. So basically dx equals minus 2 sine theta d theta, and dy is 2 cos theta d theta, and so therefore we can work out ds dt here as basically ds dt is going to be equal to the square root of dx dt squared add dy dt squared, whereas in this case it's actually theta because we're using theta instead of t, and that basically equals minus 2 sine theta squared add 2 cos theta squared, which equals 2 root sine squared theta add cos squared theta, and sine squared theta as cos squared ski 3 is 1, so that equals 2. And so basically bringing this down here now, we have the integral between theta equals pi over 2 and theta equals 0 of f of x of t y of t. Well, f, if we remember, is x squared add x plus y squared, and we know that x is 2 cos theta. That's 2 cos theta add y squared, which is 4 sine squared theta, times by ds dt, which we've already worked out is 2 times by dt, and all we have to do, d theta, and all we need to do now is to evaluate this, taking the 4 out. That equals 4 integral theta between 0 and pi over 2 of cos theta add 2 sine squared theta. Well, 2 sine squared theta is the same as 1 minus cos 2 theta d theta, and integrating that gives us 4. Cos theta integral is sine theta, add theta minus sine 2 theta over 2 between pi over 2 and 0. And just evaluating that now, that equals 4. Well, the sine of pi over 2 is 1, add pi over 2 minus sine of pi is 0. And then when we put 0 in, all of it is 0. So that gives us an answer of 4 add 2 pi. So basically the area of the vertical fence here in red is 4 plus 2 pi. And we get that basically from the line integral here. Okay, well, I hope you found that useful. If you did, please like this video by pressing the thumbs up button and subscribe to the Gresti Academy YouTube channel.